Welcome to BBS Pragati channel. In this session, let's have a look at some more design considerations of the design of MMIC SPST switch using gallium arsenide MESFET. So, let's see how we can calculate insertion loss and isolation. So, when does shunt FET offer isolation? When it is an off state. So, when it is an off state, the way you calculate isolation is equal to 10 log 1 by 1 plus Z0 by twice R whole square. So Z0 is the characteristic impedance and R is equal to R on for on state. So here shunt FET will be in on state for isolation, right? So R will be R on for on FET. Now let's have a look at the insertion loss. So insertion loss is equal to 10 log 1 plus Z0 by twice R whole square plus pi F Z0 into C2 to the power of minus 1. So, here also R is R on for on FET and R is R off for off FET. Okay, and C2 is CDS plus CP by 2. So, in case of a series FET, it offers isolation when it is an off state. So during that state you use the off condition and during the on state you use the on condition. Okay. Now based on this calculations, so the following calculations have been obtained. Now for a series FET, if the FET width increases, what happens? The insertion loss reduces and also the isolation also reduces. And in case of shunt FET, as the FET width increases, the isolation increases and the insertion loss also increases. So, in case of a series FET, if FET width increases, the insertion loss is getting reduced. So, and isolation is poor. And in case of shunt FET, if you see, as FET width is decreasing, insertion loss is minimum and return loss is better. So, based on these conditions, you should pick series and shunt configuration to attain better isolation and less insertion loss. So we'll discuss about some more design considerations in the next session. Thank you. Thanks a lot and I wish you all the best.